Ever wonder why understanding statistical formulas is so important? Well, let me tell you, statistical formulas are not just a bunch of numbers and symbols. They are the language of data. They help us make sense of the world around us, and they're used in everything from business decisions to scientific research. Consider the mean, mode, and median. These three measures are often used in data analysis and decision-making. The mean, or average, gives us a general idea of the data set. The mode, the most frequently occurring value, can indicate a trend or common choice. And the median, the middle value, offers a measure that isn't skewed by outliers. These statistical tools are like a magnifying glass for data, allowing us to spot patterns, make comparisons, and draw conclusions. And that's just the tip of the iceberg. There are many more formulas waiting to be explored. So are you ready to dive into the world of statistical formulas? First off, let's discuss the class mark. The class mark is essentially the midpoint of the class interval. You can calculate it by adding the upper and lower class limits together and dividing by 2. For instance, if your class interval is from 10 to 20, the class mark would be 15. Now, let's move on to the mean of grouped data. There are two methods we can use here: the assumed mean method and the step deviation method. In the assumed mean method, we take an assumed mean, represented as A. Then, we find the difference between each data point and the assumed mean, represented as DI. The formula for this method is x equals sign A plus phi or phi. On the other hand, in the step deviation method, we use a similar approach but add in a step deviation, represented as UE. The formula for this is x equals sign A plus h, and that's how you calculate the class mark and mean of grouped data. Easy, right? Moving on, let's talk about the mode and median of grouped data. The mode is the value that appears most frequently in a data set. For grouped data, we find the modal class, which is the class with the highest frequency. The formula for the mode is quite straightforward. It's the lower limit of the modal class plus the difference of the frequency of the modal class and the preceding class divided by twice the frequency of the modal class minus the frequencies of the preceding and succeeding classes, all multiplied by the size of the modal class. Imagine, for example, a data set where the class with the highest frequency has a lower limit of 20, a size of 5, and frequencies of 10, 15, and 12 for the preceding modal and succeeding classes respectively. Plug these values into the formula and voila, you have your mode. Now let's turn to the median of grouped data. The median is the middle value when a data set is ordered from least to greatest. The formula for the median involves the lower limit of the median class, the difference of half the total frequency, and the cumulative frequency of the preceding class, divided by the frequency of the median class, all multiplied by the size of the median class. Remember, for finding the median, the class intervals should be continuous. If not, you need to adjust them to make them continuous. And there you have it, the mode and median of grouped data explained and exemplified. Lastly, let's discuss the empirical relationship between mean, median, and mode. In statistics, these three measures are often interconnected and can be related through an empirical formula. This relationship states that 3 times the median equals the mode plus 2 times the mean. This formula might seem complex at first, but with practice, it becomes easier to understand. For instance, let's consider a data set with a mean of 20, a median of 25, and a mode of 35. By substituting these values into our formula, we can validate the empirical relationship. 3 times 25 equals 75, and 2 times 20 plus 35 equals 75 as well. Now, when you're given data expressed as less than 20, less than 25, and so forth, you should prepare a proper tabular column with class intervals and frequencies. This step is crucial for accurate calculations of mean, median, and mode. To wrap up, these statistical formulas, the mean, median, mode, and their empirical relationship are not just mathematical abstractions. They're powerful tools that can help us make sense of complex datasets, whether we're studying grades in a class, analyzing market trends, or tracking climate change. Remember, understanding these formulas can help you make sense of the world around you. So, keep practicing, and soon, statistical formulas will be second nature to you.